Okay, in problem 10, you were asked to figure out some limits. So when the limits are written like this and there's an algebraic expression there, our first instinct should be to try substitution. And substitution means take this 4 and put it where the x is. And if you can do the math and get an answer, you're done with that limit. In this case, when I do that, I end up with 3 times 4 minus 9, which is 12 minus 9, which is 3. And that is the result for letter A. 3 is the answer. Now, for letter B, we're supposed to do the same thing. We're supposed to take that -2 and put it, and put it where we see the x's. So I'm going to put a -2 in there, I'm going to put 1 there, and I'm going to put 1 there. When I do that on this problem, I get -2 squared, which is +4. -10 times -2 is +20. And then I have -24 there. On the bottom, I get -2 plus 2 when you substitute it in. And that turns out to be 0 over 0. Now, what I noticed people doing on the exam, when they saw 0 over 0, they put does not exist. And that's not true. This is what we call an indeterminate form. It means there must be some other math we can do. And often we can figure out what the value of this limit is. With polynomials, our strategy is to factor. So the idea is that we're going to try and factor x squared minus 10x minus 24. And that's one's not bad. You can pretty much do that with guess and check. And here's a hint. One of the factors needs to be x plus 2 in order for this to work. So you might as well say, hey, this one's going to be x plus 2. And if that one's x plus 2, this has to be x minus 12. Right? Because 2 times -12 is -24. And -12x plus 2x is 10x. So you factor that thing. I'm going to fix my notation here. This limit notation has to come along for the ride. Okay, so we factor it and then check it out. The x plus 2's are gone. And what we've done is we've eliminated the 0 in the denominator. We filled in the hole for that problem. And now I just do substitution and I get -2 minus 12, which is -14. And that is the value of that limit. This function just has a hole, but we can fill the hole by putting a dot where -2 comma -14 is. So that's the value of the second limit, -14. So good work if you did the substitution, but you have to interpret that 0 over 0 as an indicator that there's more math to do, and we'll usually get an answer for those. Okay. Letter C now was one of the problems that we really had challenges with. Everybody, I think, did the first part right, which was to try substitution, right? When you stick a 7 in there, you end up getting the math -5 over 0. So in the real number system, there is no limit here. This limit is technically undefined. But we've expanded our definition of a limit so that if we get a certain scenario, we're going to use infinity to describe our answer. So we know there's an asymptote over here at 7. What we're looking for is, does this function go like this, where they both go up? If that's true, we'll call it positive infinity. Or do they both go down? And if that's true, we'll call it negative infinity. Remember, if it does one of each, then you're right. It's going to be does not exist. Right? So if you look at the graph of this function, you're going to find out that it is in fact one of these, like the green arrows. Both sides are going to negative infinity. If you don't have a graph handy, you're not in trouble here. Notice we looked at this pattern in class. Notice that the power here is the 4th power. The exponent is a 4. What that means is no matter what I plug into this function, when I raise it to the 4th power, it turns positive. So that means I have a negative divided by a positive. And a negative divided by a positive is always negative. So the sign on my infinity on both sides is going to be negative. And that's why this answer is negative infinity. If you put in a 6, and you raise that side to the fourth power, you get a positive 1. Negative 5 divided by positive 1 is negative. If you put in an 8 and raise that power to 4, you're going to get a positive 1, and that is also negative divided by positive. So you test it out by looking at numbers on either side of 7, and when you raise them to the fourth power, they're always positive. So the answer to this limit is negative infinity. That was kind of a tough one. Most people stopped when they got to this part, but you don't stop there. It's not necessarily a DNE. It might be DNE, does not exist, but it's not, it doesn't have to be. Okay, finally, this last part of number 10. And on the printouts, the little minus sign next to the 2 wasn't super clear, but I made an announcement in class to make sure, hey, you know that's a 2 from the left side. So this limit is saying, hey, we want to find out just the left side of 2. And again, we're going to do substitution first. The question is, which one of these expressions am I going to substitute into when I'm coming from the left side? To figure that out, you have to look at these domains here. X is less than or equal to 2. That's the left side of 2. That means that I'm going to use the expression x plus 3 to do my substitution. Now, you don't put a negative 2 in there. It's still a positive 2. It just means we're coming from the left side. So this problem is really just 2 plus 3, which is 5. You do the substitution in the expression that meets your domain. We're coming from the left side. X is less than 2 is on the left. All right, so those are the 4 answers for number 10. 3, negative 14, negative infinity, and 5. We're getting close to the end here. 3 more videos. Take care.